Let's start with a half circle, and then from its diameter let's construct the rectangle so that its left corner is touching the left corner of our half circle and its upper base is touching the highest point in the arc of our half circle, just as shown in the sketch. Now, if we pull the chord of our half circle from the bottom left corner up until the point of intersection between the arc of our half circle and the right side of the rectangle, and say that this chord has the length of 2, is it possible for us to calculate the area of this red rectangle? If you want to try this problem for your own, this would be a great time to pause the video and then come back to see the solution. Alright, let's get to the solution. So, for this particular problem, I will offer you 4 different methods to solve it. First, let's try the method number 1 of using the Pythagorean theorem. For this method, I will first mark the center of the half circle as O, and I will mark all the vertices of our rectangle as A, B, C, and D. I will also mark the intersection point between the half circle and the height of the rectangle as E. Now, let's say that the length of our rectangle has the value of A, and the height of our rectangle has the value of B. If we slide the height of our rectangle to the point O, you can see that it also represents the radius of our half circle, so we can rotate it down. Now, if we clear the image a little bit and say that the length OB is equal to x, we can clearly see that lines AB and DC have the same length because they are both bases of our rectangle. That means that the combined lengths of the line AO and OB must be equal to the line DC. Now let's substitute our values from the image and we will get the following. From here we can conclude that x is equal to the difference between the base and the height of our rectangle. Now let's go back to our sketch. Here we will again rotate the radius B up until the point E. Now, since we know that the angle at the point B is the right angle, we can notice that we now have this purple right triangle OBE, and we can use the Pythagorean theorem for this one. We can say that hypotenuse OE squared is equal to leg OB squared plus the leg BE squared. We can substitute our values from the sketch and get the following. Now we can simplify this and say that b squared is equal to b squared minus the quantity of a minus b squared. Now we will use the formula for square of binomial. Just to remind you guys, the formula for square of binomial states that quantity of a minus b squared is equal to a squared minus 2 times a times b plus b squared. So we can apply this formula for our second term, and we will get the following expression. Now we can lose the brackets and we can cancel b squared. And from here we will get that b squared is equal to 2 times a times b minus a squared. Now if we slide our line A down to the line AB, you can see that AB also has the length of A. And you can notice another purple right triangle ABE. We can write Pythagorean theorem for this one as well. So a squared is equal to ab squared plus be squared. Now we can substitute our values and get the following. We can simplify this, and since we already know the value of be squared from our first equation, we can just substitute that value in and we will get the following equation. Here we can cancel a squared and we are left with 4 that is equal to 2 times AB. But now, since we know that the area of the rectangle is equal to the product of its length and its height, we know that area is equal to A times B in our case. So we can substitute that in and we will get that 4 is equal to 2 times the area of the rectangle which means that the area of our red rectangle is equal to 2 squared units, and this is our solution. Alright, let's do method number 2 now, the method of using the triangle similarity. For this method, we will again mark the center of our half circle as O, and then we will mark the endpoints of our chord as A and B. Let's also mark the bottom right corner of the rectangle as C and the bottom right corner of our half circle as D. Now let's say that the height of our rectangle is equal to B and the length of our rectangle is equal to A, just as in our previous method. Now we can notice that the angle at the point C is the right angle, so we will first take a look at this green right triangle ABC. This right triangle has the hypotenuse of 2 and the leg of A. Now let us pull a line from the point B to the point D. And let's notice that the height B represents the radius of our half circle. So that means that if we rotate it, we will get that the line AD is equal to 2 times B. Now let us try to prove that the angle at the point B is also the right angle. We can do this by using the inscribed angle theory, which states that if we have a circle and we have the inscribed angle in this circle, let's mark it as theta, that inscribed angle will always be equal to the half of the measure of the central angle that subtends or forms the same arc, in this case that is 2 theta. So now if we mark all our points the same way as the sketch on the left, you can notice that we have the same situation on the sketch on the left. So we can say that the angle at the point O represents the central angle and it is equal to 180 degrees. This angle corresponds to the angle 2 theta. So that means that the angle at the point B corresponds to the angle theta, and it is exactly half of our central angle of 180 degrees. So that means that the angle at the point B must be a right angle. Alright, so now with this in mind, we can notice another right triangle ADB. Let's also isolate this right triangle and let's rotate it so it is in the same position as our green right triangle. We can notice that this right triangle has the hypotenuse with a value of 2b and the leg with the value of 2. Now, since both of these triangles have the 90-degree angle and they both share the angle at the point A, this means that these two triangles are similar. Now we will use the rule of similarity, which states that the relation between their sides must be the same. So from here we will substitute our values and get the following. Now we can simplify this by cross-multiplying and we will get the following. We can simplify it even more and get that A times B is equal to 2. Again, as before, we know that the area of the rectangle is equal to A times B, so if we substitute that value, we will get that the area of our red rectangle is again equal to 2 squared units. Alright, let's do the method number 3 now, the method of using the intersecting chord theorem. For this method we will do something a little different. Let's mirror our image on the bottom side so that we get the full circle. Now let's again say that the length of the rectangle is A and that the height is B. And let's use the intersecting chord theorem. Just to remind you, the intersecting chord theorem states that if we have the two chords that intersect, in this case chords AC and BD, and they intersect at the point P, we know that the product of the segments AP and PC must be equal to the product of the segments BP and PD. Now let's mark our sketch on the left the same way as we did for our sketch on the right. And you can notice that again we have the chords AC and BD. Now let's try to find the values for our segments. We can see that the segment AP has the length of A, and from our previous method we shown that the segment AC is equal to 2B. Now, if we clear our image a little bit, we can see that the line AC must be equal to the line AP plus the line PC. So, if we substitute our values, we will get the following. So, the length of the line PC must be equal to 2B minus A. And we have our segment. Now let's try to find the segment PD. For this, we will again notice that the angle at the point P is a right angle, which means that the triangle APD must be the right triangle, and we can use the Pythagorean theorem. We can say that the hypotenuse AD squared must be equal to the leg AP squared plus the leg PD squared. Here we can substitute our values and simplify to get the following. And now we can conclude that the PD squared is equal to 4 minus A squared, which means that the length of the segment PD is equal to square root of 4 minus A squared. But we know that the length BP must be equal to the length PD, because the image is symmetrical. And that means that the length BP must have the same value as the length PD. Alright, now we have all our segments and we can substitute them in our formula and get the following expression. Now we can simplify the left side of the equation by multiplying the brackets with A, and on the right side we will lose the square root to get the following. We can now simplify this by cancelling A squared and get that 2AB is equal to 4, which means that A times B is equal to 2. Again, we know that the area of our rectangle is equal to the product of the length and the height, so that is A times B, and if we substitute that in, we will get that the area of our red rectangle must be equal to 2 squared units, and again we have our solution. Alright, now let me show you the method number 4, the method of the limit case. This is by far the most boring method, but I'm going to include it because I want you guys to see this method as well. So let's mark the point of intersection between the arc of our half circle and the right side of our rectangle as A. You can notice that this point is an arbitrary point. So what if we have the limit case in which this chord with the value of 2 is actually the diameter of our half circle? That would look something like this. Now, with this in mind, we can easily conclude that the radius of our half circle is equal to 1. So, if we rotate it and slide it to the right, you can see that the height of our rectangle has the value of 1. Since we know that the area is equal to the product of the base and the height of the rectangle, that means that our area is equal to 2 times 1, which means that the area of our red rectangle must be equal to 2 squared units, and again we have our solution. I hate this method personally, but I have to include it as well. Alright, I hope you guys enjoyed this video. If you did, give it a like and subscribe to the channel for more content like this. Of course, if you found another method to solve this particular problem, please write it down in the comment section below. And as always, see you guys and take care.